set out here.
Hang on a second.
Well, welcome to the Computer Security Seminar at Purdue University. Our speaker today is Ehab Al-Shaer from DePaul University. He's Associate Professor of Computer Science and Director of the Multimedia Network Research Lab. His topic today is toward autonomic security policy management. He changed the screen on me right while I was reading.
Oh,
Ehab.
sorry. Thank you. Let me just do one more of this control here to see if it comes here. CD and VGA. Okay, great. Something had worked with me today. Thank you very much for inviting me here, and sorry for being late here in this talk, but I never thought that Lafayette is closer to New York than Chicago. So I thought it's really the same time zone. So I just figured it out in my way here when I was talking by coincidence. That is, we are in difference 1 hour. So I'll try to make this talk short and to the point. And I will also skip some slides because of this delay. So I'm glad to be here, and I will be talking to you about the autonomic means automated, self-automated management for security policies. And I will focus on two issues or two aspects of security management: verification and optimization. Here's the outline of the talk. So we will first set the ground for the challenges of the next generation security policies. We'll talk a little bit about what is a security policy and what are the current challenges that security policies is facing. Then we'll talk about our contribution in this area in two folds: the verification aspect and the optimization aspect. Verification means how is your security policy is correct? How can you tell if your security policies is consistent and is good enough for your enterprise, for your network? And second one, optimization, means how can I make my security policies as powerful, as efficient as supposed to be? So these are two issues in security are very important. The first one is correctness. How can I make sure my policy is correct? Second one is performance. And we cannot trade one for another. We always have to look for correctness and performance. No one here in this room would like to go and purchase 100% verified, correct protocol, but it will make him wait for an hour to do a transaction on the internet. And no one also would like to go and get something really cheap and fast, but it has a lot of holes and bugs. Somebody else might steal your, it's not correct, means it's not correct because somebody else might steal your password or your credit card information. So correctness and speed or performance, both are important objectives that sometimes we have to compromise between them. Then we're going to show some evaluation and talk about related work. This is just a snapshot of the Multimedia Lab. This is the selected set of projects is running there. As you can see, we focus mainly in policy management that centered around 4 major themes: verification, optimization, testing, evaluation for security policies. And we do have some other projects in different directions too. There's the members of the Multimedia Lab. Their names are also on the web, and sponsors. This research is sponsored by Cisco Systems, Inter Research, Aramco, Sun Microsystems, and NSF. Here is what I can frame out as a security system that has algorithms, protocols, and also policies. Many people in the past, they have an extensive research and conduct an extensive research in the area of protocols, security protocols, and security algorithms. Very little attention has been made to the policies. But for your attention, policies is the one actually controlling algorithm and protocols. So if we have misbehaved policy, misconfigured policy, then algorithms and protocol does not help anymore. So this is why attention has to go to the policies, not only to the protocols, which is maybe correct, and algorithm. In other words, if you have a correct protocol, verifiable protocol, as well as an algorithm, it doesn't mean that you have a secure system until you have a secure policy or correct policy. Now, what are the challenges in security policies pertaining management of these policies? And I'm talking here about verification and configuration. How can you know if your policy is correct? How can you configure your policy in a large-scale network? This is a real challenging problem for anyone who works in the field of network security, have any exposure during internship or any kind of collaboration in the industry. You would know that any network security device has a policy. What do we call it? A policy that's manually configured through a system administrator. And this policy is basically a set of rules, simple rules, that specify what packets to allow, what packets to deny. As simple as that. It's an access control rules, tell you what packets being permitted, what packets should be declined, or what traffic should be declined. These policies, although is a rule-wise policies, are really complex in terms of semantics, because the order of the rules gives you a different meaning. Means I can have the same set of same set of rules. If I just flip the order, give you a different behavior. Every time you change the order of the rule, most likely you will get a different semantics. So it's not syntactically what's important. It's semantically what's important here, because we would like to understand how this policy behaves, and that's related to semantics. And this semantics is complex because first, you have to give attention to the rule order. Second, you have to consider policies with different matching semantics. Firewalls, for example, if a rule triggers, if a rule matches, it immediately stop any more analysis. Packets come in, rule matches, that's it, stops there. IPSec, doing it differently. If a rule match, it's going to look for another match. So it might have multi-trigger, what we call it multi-trigger, versus single trigger. So different security devices have different way to match packets. That means your policy also has to go with this. Not only this, but the number of rules that could exist in a single firewall, just single firewall, could vary to up to 15,000 and sometimes 20,000 rules in one single firewall. A very reasonable number of rules in one single firewall, 1,500. It's just a mid-sized enterprise, 1,500 rules. And you need to know that all these rules are correct and they are in the same order. Okay, order semantics is important. In addition to this, I'm just giving you that just as a complication and the challenges of managing security policies. That these policies, which resides in devices, they are not in isolation from each other. Means one policy in firewall might affect another policy in another firewall. So they are interacting with each other globally to form what we call it the global network security policies. So here you are not looking at single device verification, but also you're looking at the interaction between devices and the interaction between the policies of these devices. So you can see how much the problem complexity is exponentially increasing as we look at the number of rules within device and the number of devices within your network. I was giving similar talk in Intel Research 6 months ago, and they told me that in their enterprise, in their network or enterprise, just in their local California, Folsom, Sacramento area, they have more than 20,000 firewalls, including the firewalls in the hosts. Host firewall as well as network firewall, more than 20,000. Everyone can go and download a firewall in his machine or in his desktop or laptop and just configure it. Nobody can prevent you. So we have that now. You have to remember that your firewall that you put in your machine is not the